So light is a form of energy which gives sensation of vision, and we will be studying few phenomena shown by light, including reflection, refraction and dispersion of light. The others you will be studying in your higher classes. Then we come to the laws of reflection of light. This is a diagram which is representing a light ray which is incident on a mirror and it being reflected back. Okay, so angle I here is representing the angle of incidence, that is the angle between the incident ray and the normal, and angle of reflection is the angle between the reflected ray and the normal. According to the first law of reflection, both these angles are equal. Angle I is equal to angle R. And the second law says that the incident ray, the normal at the point of incidence and the reflected ray, all these three will lie on the same plane. They lie in the same two-dimensional surface. Okay. Alright, so here you are given an incident ray which is making an angle of 30 degree with the mirror. Okay, and you have to find the angle of reflection. So we start from the law of reflection which says angle I is equal to angle R. Okay, that is the law of reflection, and angle I here is given as 30, so that means angle R will also be 30. So that is diagrammatically represented here since the law of reflection of light. So this was a straightforward numerical where incident angle is given to you. You have to find the angle of reflection straight away using the law of reflection of light. Alright, so in another situation you have to find the angle of reflection, and this time incident angle is not given. The angle of the incident ray making an angle of 50 degree with the mirror is given. So first step is calculating the angle of incidence. That we do by this form, because we know normal is 90 degree with the mirror. So this angle will be 90 minus 50, so that is 40 degree. So we found the angle of incident here first, which is 40 degree here. So this is 40 degree. And now applying the law of reflection of light which says angle I is equal to angle R, I can straight away write angle R is also 40 degree. Okay, so the difference between the previous question and this one was that this time angle of incidence was not directly given in the question. You had to calculate it. The angle which the incident ray is making with the mirror is given. Okay, so if a light ray is incident perpendicular to the plane mirror, in that case you will observe that the light retraces its path. Okay, because if the light is incident perpendicular, that means the angle of incidence is 0, and if angle of incidence is 0, then angle of reflection will also be 0 by the law of reflection of light. So in the first question, angle I and angle R being same, the light is retracing its path after reflection. Now in another situation, two mirrors are perpendicular to each other, and this is the incident ray which is falling on the first mirror at an angle of 30 degree. You have to find the angle of reflection from the second mirror. So what you are going to do is, पहले जो first mirror पे ये light ray आ रही है, इसकी reflected ray आप बनाएंगे, and that reflected ray will strike the second mirror and again get reflected. Okay, so this is the path followed by this light ray. It first strikes the first mirror, reflected at the same angle. Why? Because of the law of reflection of light. So that is what we have written here. Angle I is equal to angle R, and I have labeled these angles as X, Y, I and R. So angle X is also 30 because angle I is equal to angle R. Then coming back to the diagram, here the angle X and angle Y, they are alternate interior angles, so they are going to be equal. So if X is 30 degree, Y will also be 30. Alternate interior angles they are. So we have mentioned that here angle X is equal to angle Y, 30 degree. Then this angle Y is the angle which this ray is making with the mirror. So angle of incidence निकालने के लिए हम 90 minus Y कर रहे हैं. So that is 90 minus 30, that is coming out to be 60 degree. Okay, and since angle of incidence on the second mirror is 60 degree, so the angle of reflection from the second mirror will also be 60 degree, again following the law of reflection of light. So let us consider the situation where these two mirrors are perpendicular to each other. Let this be mirror 1, this is mirror 2 at 90 degree to each other, and there is an light ray which is falling on this mirror at an angle of 54 degree with the mirror. Now remember, this is not the angle of incidence. This is the angle which the incident ray is making with the mirror. So to find the angle of incidence, I will drop a normal on this mirror, and this angle now, which is the angle between the incident ray and the normal, will be the angle of incidence. So this will be 90 minus 54, so that will be 36 degree. Now if I want to draw the reflected ray here, so that would be going somewhere in this direction at an angle of 36 degree with the normal. Angle I is equal to angle R. So extending this mirror, now this light ray is striking the second mirror at what angle? That is what we'll have to find out. Now this angle is 36, so that means this angle must be 36. Why? Because these are alternate interior angles. Okay, now if this
So
is
the
36,
characteristics of the
I
image formed
drop a
by a
normal
plane
here,
mirror are
and I'll have the
that
angle
the
of
images are
incidence on
virtual
this
and
mirror
direct.
as
The size of the
54
image is
degree, and
same as
hence
that
the
of the
angle of
object.
reflection also
Image is at the
from
same
this
distance
mirror would be
behind the mirror as the object is in front
54
of the
degree,
mirror,
since angle I is
and the
equal to
image
angle R
formed
as
is
per the
literally
law
inverted.
of reflection
That
of
is,
light.
the right hand side
So
of the
this
object
is
seems
the
to be the left, and
incident
vice
ray
versa.
given in the question. This is the reflected ray from mirror 1. When this ray strikes mirror 2, this is the reflected ray from mirror 2. Alright, so this is the ray diagram for the image formation by a plane mirror. O here is representing the object, and these are the two light rays which are emerging from O. They strike the mirror at the point as shown in the diagram. Okay, and at the 2 points where the rays are striking, I have dropped the normals, and reflected rays are hence drawn keeping in mind the law of reflection at these points. Angle of incidence and angle of reflection same. Okay, and these reflected rays enter the eye of the observer. When produced backwards, we can locate the position of the image, and you will observe that the object distance, that is the distance between the object and the mirror, is same as the image distance, that is the distance between the mirror and the image. This is one of the important properties of the image formed by plane mirror. Also, the other properties are: 1. The image is virtual and direct. Next, it is always laterally inverted. Third point is that the distance between the object and the image is same from the mirror. Okay.
Okay, so we are discussing the differences between real and virtual images. On your screen, you can see there is an experimental demonstration for the same. There is a magnifying glass जिसके थ्रू कैंडल फ्लेम अगर हम देख रहे हैं, आप देख सकते हैं स्क्रीन पे उसकी इन्वर्टेड इमेज बनी हुई है. ओके, रियल इमेज है क्योंकि वो स्क्रीन पे आ गई है एंड इट्स एन इन्वर्टेड इमेज. ऑन द अदर हैंड, यू कैन सी अ वर्चुअल इमेज बीइंग फॉर्म्ड बाय अ कन्वेक्स लेंस है. ठीक है, उसमें आपको इमेज जो है वो सिर्फ लेंस में ही दिख रही है, वो वॉल पे प्रोजेक्ट होती हुई नहीं दिख रही. ओके, सो इन दैट केस a virtual image is being formed. Okay, so ये जो स्क्रीन पे आप अभी देख रहे हैं, that is depicting real image and virtual image being formed, और इनको देखकर हमने differences list out किए हैं real और virtual images के बीच में. The first difference is that real images are formed by actual intersection of light rays, whereas virtual images are not formed by actual intersection. ठीक है, वो हम सिर्फ प्रोड्यूस बैकवर्ड करके बनाते हैं लाइट रेस को, जैसा हमने प्लेन मिरर के केस में भी बनाई थी. ठीक है. Second is real image can be obtained on a screen, that you can see in this demonstration also कि real image जो है वो wall पे आई हुई है inverted. Okay, real images can be obtained on a screen, whereas virtual image cannot be obtained on a screen क्योंकि वो बनी नहीं रही है actual intersection से, it cannot be obtained on a screen. Okay, and the third difference is that real images are always inverted. On your screen also you can see the image that is formed is inverted. Okay, and virtual images are always erect. The virtual image that you see of yourself in plane mirror, that is always erect. It's a virtual image, it's of the same size, है ना. Whereas real images, they are always inverted. हमारा आई लेंस जो इमेज बनाता है हमारे रेटिना पे, that is a real image, it is always inverted. So these are the differences that we have listed for real and virtual image. Okay. Okay, so differentiating between Regular and diffused reflection. This diagram here is representing regular reflection, a smooth surface, plane mirror, parallel light rays are incident, okay, and after reflection also the light rays are parallel only. Keeping in mind the laws of reflection, angle I equal to angle R, the parallel light rays are reflected as parallel light rays only, okay. Whereas in case of diffused reflection, when parallel light rays are incident on an uneven surface, जहां जहां पे लाइट रेज इंसिडेंट हुई है मैंने उस पॉइंट पे नॉर्मल ड्रॉप किया, ओके. यू कैन सी द नॉर्मल in all the three cases is also having a different orientation. यहाँ पे सरफेस बिल्कुल स्ट्रेट थी, नॉर्मल्स बिल्कुल परपेंडिकुलर थे. यहाँ पे सरफेस ही अनइवन है तो दी नॉर्मल्स आर आल्सो टिल्टेड, ठीक है. यहाँ पे एग्जैक्टली 90 डिग्री है, यहाँ पे जो 90 डिग्री है वो सरफेस ही शिफ्ट हुई हुई है तो 90 डिग्री वाला नॉर्मल भी थोड़ा सा टिल्टेड है. सेम इज द केस हियर, जो सरफेस का पॉइंट ऑफ इंसिडेंस है वो थोड़ा सा टिल्टेड है क्योंकि द सरफेस इज नॉट स्ट्रेट, तो नॉर्मल उस हिसाब से 90 डिग्री बनाने के लिए भी थोड़ा सा टिल्ट हो गया, ओके. एंड नाउ इन ऑल दी थ्री रेज एंगल आई इक्वल टू एंगल आर ध्यान में रखते हुए यू कैन सी ऑल दी reflected rays are not parallel to each other, okay, and that is why the intensity of the image will be lower. We'll get a dull image here, so that is diffused reflection. These are the differences between diffused and regular reflection.
Kaleidoscope is an application of the multiple reflections of light. It is a toy which contains plane mirrors, and due to multiple mirrors there are multiple reflections of light. So let us suppose these are the three rectangular plane mirrors which are arranged in the form of this pyramid, and once they are fixed in the form of this pyramid they can be put into a tube, and some pieces of broken bangles or beads can be put at one end, and due to multiple reflection we can observe beautiful patterns being formed. Another application of multiple reflection of light is a periscope. The periscope is a device which is used to see objects which are not at the same level as our eyes. The phenomena that explains the working of a periscope is the multiple reflections of light. Let us understand the working of a periscope. This is the diagram of a periscope which shows a tube with two bends at 90 degree, and the light from the object, which here is an apple, is falling on the first mirror. It bends at 90 degree, falls on the second mirror, and then enters the observer's eye. Now clearly you can see if the incident ray and the reflected ray are making an angle of 90 degree with each other, that means the angle of incidence and reflection must be 45 degree. And it is due to this that the mirrors are also placed at an angle of 45 degree with respect to the incident ray. Let me explain you in detail. So if this complete angle is 90 degree, that would mean angle of incidence plus angle of reflection is 90 degree. And since both these angles are equal, I can replace angle R as angle I only. So this becomes 2 angle I, which is 90 degree, or I can say that angle I is 90 by 2 or 45 degree. So angle of incidence and angle of reflection both are 45 degree here at both the reflection points, and hence the mirror also is placed at an angle of 45 degree. So with respect to the incident light, the mirror is placed at an angle of 45 degree. This angle is 45 degree because the angle of incidence is also 45 degree. So mirror is at 45 degree with respect to the incident ray.
Okay, so human eye is the organ that helps us to look around the things, and human eye approximately 2.3 centimeter in diameter. This is the structure of the eye. The front layer of the eye, from where light enters, is known as the cornea. Maximum bending of light takes place here. Okay, then comes the iris. It's a dark muscular diaphragm that gives color to the eye. Okay, and now next to the iris is placed a crystalline lens or a convex lens, which is made up of proteinous jelly-like material. Okay, it's a convex lens, so whatever light is falling inside the eye on this lens, it is going to form an image, and that image will be formed on the retina, which is a photosensitive film inside the eye. Okay, now this lens is held in its position with the help of these ciliary muscles. Ciliary muscles have two jobs to do. One, holding the lens in position, and the other is adjusting the thickness of the lens. Now, why do we need to adjust the thickness of the lens? That is to view the objects at different distances. When the objects are near to the eye, the thickness of the eye lens will increase. When the objects are far away from the eye, the thickness of the eye lens will decrease. Okay, now this increase and decrease in the thickness is done by the ciliary muscles. Okay, now the light falling on the lens will pass through this pupil. ओके आइरिस ने जितना एक्सपोज्ड एरिया छोड़ा है लेंस के लिए, उस एरिया को, उस पोर्शन को हम प्यूपिल कहते हैं. ठीक है, लाइट इज अल्टीमेटली एंटरिंग inside the eye through this
discuss the defects of
opening
vision.
called pupil.
We'll be discussing three defects of
And
vision.
after the convex
First one
lens
is
has
myopia
converged
or
the light,
nearsightedness
the real
or
inverted image is
short-sightedness.
formed on the
In this
photosensitive
defect,
film
the
called
person can
retina.
see nearby objects
Retina has
clearly,
two
but
types of
cannot see
cells,
far
rods
away
and
objects
cones.
clearly.
That name is given to them depending on their shapes. Rods are rod-like shaped, and cones are conical in shape. Cones are sensitive to colors, and rods are sensitive to the intensity, dim light. Okay. Then comes the nerve endings, which are going to the brain via this optic nerve. All the signals that are generated when the light falls on the retina, they are carried to the brain via the optic nerve. And the junction where the nerve is going into the brain, the nerve endings are going to the brain. When light falls at the junction, it will not be red. It cannot be seen. So we call that spot as the blind spot. Okay. Also here we have shown how the iris and pupil work in collaboration. When bright light falls on the eye, the iris expands and the pupil shrinks, and very small amount of light enters the eye. Okay, this is a protecting mechanism which is there. Okay, if बहुत ज़्यादा bright light enters the eye, it can damage the eye. तो आई का ही अपना रिफ्लेक्स है प्रोटेक्ट करने के लिए. जैसे ही ब्राइट लाइट आती है, आइरिस कवर कर लेता है प्यूपिल को ताकि कम से कम लाइट एंटर करे. ऑन द अदर हैंड, वी हैव शोन द आई व्हेन इट इज इन डिम लाइट. ओके, जब कम लाइट फॉल कर रही है तो आइरिस इज मूविंग बैक, प्यूपिल का साइज एक्सपैंड हो रहा है ताकि ज्यादा से ज्यादा लाइट एंटर करे आई में, एंड द पर्सन कैन सी द पर्टिकुलर ऑब्जेक्ट. ओके, सो दैट इज द ब्रॉड स्ट्रक्चर ऑफ द ह्यूमन आई. We have done a very few labelings here, only the ones which are there in your syllabus of class 8. When you move to higher classes, you will have a few more labelings in this diagram. Alright, so these are the functions of the various parts of the eye, starting with cornea, that is the front transparent layer of the eye from where light enters. Maximum bending of light takes place here. Then comes the iris, which is a dark muscular diaphragm that gives color to the eye. Pupil is the opening within iris from where light enters into the eye. It controls the amount of light entering the eye. Okay, we had discussed in bright light pupil will become small, and in dim light it will widen. Then comes the convex lens. It's a converging lens made up of proteinous material, and it forms real and inverted image of the objects in front of the eye.
Third defect of vision that we are discussing
And then
is
is the ciliary muscles.
It is a
They
material
hold the
condition
lens in
which the
position
eye lens
and adjust
becomes
its thickness
progressively cloudy,
according to the
resulting
distance
in
of the object
blurred
from the
vision.
eye. When the objects are close to
This
the
is
eye,
due to the
the thickness
formation
of the eye
of a
lens
membrane
increases.
over the eye
When the
lens.
objects are far away from the eye, the thickness of the eye
Vision
lens will
decreases gradually,
decrease.
and it can lead to total loss of
Okay, so
vision.
retina is a photosensitive
The
layer
vision
with
can be
millions of
restored by
photosensitive
surgery,
cells called
in
rods
which
and cones.
the eye lens having
Rods are
cataract
sensitive to dim
is
light,
removed from
cones are
the eye,
sensitive to color, and
and
these
a
cells
new
convert
artificial
light
lens
into
is
electrical
inserted in
signals.
its place.
ओके, और इसी रेटिना पे रियल एंड इन्वर्टेड इमेज बनती है ऑब्जेक्ट्स की. ब्रेन हेल्प्स अस टू व्यू देम एज इरेक्ट. हमें चीज़ें इन्वर्टेड नहीं दिखती हैं, ब्रेन हमें हेल्प करता है ये रियल इन्वर्टेड इमेज को वापस इन्वर्ट करने के लिए और ऑब्जेक्ट्स को एज इरेक्ट देखने के लिए. ठीक है, सीधा देखने के लिए. देन कम्स द ऑप्टिक नर्व विच कैरीज ऑल दीज इलेक्ट्रिकल सिग्नल्स टू ब्रेन. So this is the defect myopia. This is representing here the normal eye when it is viewing the far away objects. Parallel light rays are representing light coming from infinity, yeah, very far away. Okay, and after they fall on the eye lens, bending takes place and the image is formed exactly at the retina. Whereas in case of a myopic eye, these light rays will not meet at the retina, they are being converged, they are forming an image in front of the retina. This is because the eye lens has become more converging. Okay, and so the image formed will not be a clear image that is obtained on the retina. Since the image is formed in front of retina, whatever light is falling on the retina, that is not forming a clear image, sharp image नहीं बन रही है, blurry vision हो जाएगा. So hypermetropia or farsightedness or long-sightedness. Okay, in this a person can see far away objects clearly but cannot see nearby objects clearly. Okay, so this here is representing the normal eye. Normal eye में nearby object जो हमने रखा है, say approximately 25 centimeter, वहाँ से point object से light rays are falling on the eye lens and they are being converged at the retina. So normal eye viewing a nearby object. The same object when is placed in front of a hypermetropic eye, the light rays will fall on the eye lens and the eye lens will not be able to converge these light rays at the retina. Okay, you can see the light, if I produce forward, it will converge and form an image beyond the retina. So that is a hypermetropic eye. So this can be corrected by using a converging lens or a convex lens.
So this is a convex lens or a corrective lens for hypermetropia, and this is the nearby object. So when light rays fall on this corrective lens or convex lens, they will bend and fall on the eye lens, and this eye lens will perform further bending of these light rays and the image will be formed exactly at the retina. So this is the corrected eye for hypermetropia.
So this is white light entering the glass prism, and we have placed a screen next to the prism so that we can see the colors coming out of the prism. So this white light, when enters the glass prism, it is going from a rarer medium to a denser medium. It's going from air to glass. So if the glass prism was not there, the light would have followed this path. It would have gone straight. But since we have a medium and light is going to bend, we observe that light not only bends but it splits into its constituent colors. And we can obtain these colors on the screen that we have placed next to the prism, and we call this band of 7 colors as spectrum. So very important, mark the directions of the colors, and we remember the sequence of these colors as Vibgyor. So violet, indigo, blue, green, yellow, orange and red. You can clearly see here that violet is the color which has gone through maximum bending and red is the color which is least bent. These colors have different wavelengths, and that is the reason why they bend at different angles when they pass through the glass prism. Rainbow is a natural spectrum that we observe in the sky after a rain shower. The water droplets suspended in the atmosphere start behaving like tiny prisms, and they disperse the sunlight into its constituent 7 colors.